Assalamu alaikum, dear students. How are you? Hope you are fine and safe in this pandemic situation. Welcome to my physics class. I am Mafrun Shati. Today I am here to take the class for HSC level, HSC Physics second paper, chapter 3. Today's topic, Joules law for generation of heat. Before explaining Joules law for generation of heat, I am to explain heating effect. What is heating effect? The heating effect of electrical current when it travels in a circuit is because of collision among electrons of wire. Especially, what is the amount of heat generated during the flow of current through a wire. Look at the figure. Here, there is the calorimeter. Here we have given some water, and for measuring the temperature, we have immersed a digital thermometer in the water, and there is a coil, heating coil, and this is lagging. Lagging means material that provides heat in insulation for a water tank, pipe, etc. There is a lead, and the coil is connected with an external circuit. There is a source of electrical energy, that is battery. So when the switch is on, then what will happen? Then the current will flow through the wire. Current flow means nothing but the flow of electron. So when electron flows through the wire, then electron gains kinetic energy, because you know kinetic energy is gained due to the motion of the electron. So when electron, I have told you this is the coil. The resistance of this coil is very high. So when electron moves through the wire, the electron will have, when you have collision with the atoms or molecules of the wire, then what will happen? Electron will share its kinetic energy with those atoms or molecules in the form of heat or thermal energy. As a result, by passing of electricity through the wire, heat will be generated, and heat is generated that can be measured by using this digital thermometer. So this is known as heating effect of current. Now I will explain you Joules law for generation of heat. There is a historical background. In 1841, the famous English scientist J.P. Joule, from the experimental results, stated 3 laws relating to heat generated due to the flow of current through a conductor. In honor of Joule, these laws are called Joule's law of heat. Those laws are stated below. First law. First law is law of current. The amount of heat produced in a current conducting wire is proportional to the square of the amount of current that is flowing through the wire when the electrical resistance of the wire and the time of current flowing are constant. If the resistance R of the conductor and the time T of flow of current remain constant, the heat generated due to the flow of current I is directly proportional to the square of the current, such that H is proportional to I square if R and T remain constant. Dear students, in my previous lecture, I have explained how heat is produced by passing of electricity, and there I have shown you the formula of generation of heat. H is proportional, H equal to I square RT. From my first lecture, you got it. H equal to I square RT. So, if R and T remain constant, then H will be proportional to I square. That means the more will be the current, the more will be the generated heat. And if current is twice, generated heat will be 4 times. So the explanation of the law is given below. Meaning of this law: if the current in the conductor becomes double, the heat generated will be 4 times of the initial heat. If the current is made half, generated heat will be 1/4 of the initial value. So if current I1, I2, I3 flow through a conductor for the same duration and respective heat produced are H1, H2, H3, then the first law can be written as h1 by I1 square equal to h2 by I2 square equal to h3 by I3 square equal to constant. Now the second law. Second law is known as law of resistance. If current and time of flow remain constant, then heat produced in a conductor due to the flow of current is directly proportional to the resistance of the conductor. That means H is proportional to R, where I and T are constant. Meaning of this law: if the resistance of the conductor is either double or half, the heat produced in the conductor will be respectively double or half. That means the more the resistance, the more will be the heat. The less the resistance, the less will be the heat. This type of effect you can observe in your practical life also. Okay, you use iron for ironing your clothes, especially your school dress or other clothes. So while in the iron there is a wire known as nichrome, and the resistance of the nichrome wire is very high. That means the coil of the iron is made of nichrome wire, and when electricity passes through that wire, then it gets much heated. So the resistance here the resistance is very high. That's why the generated heat will be very high. So if current I flow for the time t through the resistor R1, R2, R3 connected series and generated heats are respectively H1, H2, H3, then the second law can be written as H1 by R1 equal to H2 by R2 equal to H3 by R3 equal to constant. Look from here, H is proportional to R. So we can write H. If we remove this the proportional sign, then we will take a constant here. So we can write H by R equal to constant. Now the third law. Third law is known as the law of time. The heat generated due to the flow of current is proportional to the time of current flowing when the electrical resistance and the amount of current are constant. If the resistance of a conductor and current flowing through it remain constant, then the heat generated in the conductor due to the flow of current is directly proportional to the time of flow of current. Here, H is proportional to time. That means how long the current will be flown through that conductor. The generated heat will depend on that time. The more the time for which current flows, the more will be the generated heat if current I and R remain constant. Now, meaning of this law. If the time of flow of current becomes either double or 4 times, generated heat in the conductor will be respectively double or 4 times the initial value. So for the same current flowing through a resistor for T1, T2, T3 seconds, and the generated heat in the conductors are respectively H1, H2, H3, then H1 by T1 equal to H2 by T2 equal to H3 by T3, that is equal to constant. So here from the above explanation we get 3 laws, that is law of current, H is proportional to I square, law of resistance, H is proportional to R, law of time, H is proportional to T. By combining all these 3 formula we get H is proportional to I square RT. Here if we omit this proportional sign, we will take equal sign and we have to use a constant here. This constant is known as constant of proportionality or proportionality constant. It depends on the units of different quantities used in equation 1. If H is expressed in calorie, I in ampere, R in ohm, and T in second, then K equal to 0.24, where this K can be written as 1 by J. This J is known as joules mechanical equivalent. Dear students, do you understand? Now I will show you a video which makes you more clear.
Let us discuss about Joule's law of heating. This is also known as ohmic heating and resistive heating. We all observe that when an electric current passes through a conductor, some heat is released. The amount of heat released is proportional to the square of the current and also proportional to the resistance of the conductor. This simple relationship is known as Joule's law. Now let's discuss about historical background of this law. Resistive heating was first studied by James Prescott Joule in 1841. He immersed a length of wire in a fixed mass of water and measured the temperature rise due to a known current flowing through the wire for a 30-minute period. By increasing and decreasing the current and the length of the wire, he observed that the heat produced was proportional to the square of the current multiplied by electrical resistance of the wire and time during which the current was flowing. If we formulate this, we will get amount of heat H is proportional to square of current I. H is also proportional to electrical resistance R and proportional to T. That means H is proportional to I squared into R into T, which can be rewritten as H is equal to 1 by J into I squared into R into T, where J is a constant known as Joule's mechanical equivalent of heat. Mechanical equivalent of heat may be defined as the number of work units which, when completely converted into heat, furnish 1 unit of heat. Joule's heating is independent of the direction of current. If we look at the phenomenon from atomic level, we can see the flow of electric current is nothing but flow of electrons. Hence, there will always be resistance from the fixed atoms of the wire. The fixed atoms of the wire resist the flow of electrons, and as a result there are collisions. And as the kinetic energy converts into heat energy, we see the wire is getting hot. Thank you.
Dear student, there is a mathematical problem for you. You must solve this maths by tomorrow morning and send it in my messenger, inbox it to me. I will check it. Thank you, everybody. There is a moral for you. The future belongs to those who believe in the beauty of their dreams. Dear students, try to feel this moral by your heart. Goodbye, everybody.